Setting up a network without securing it is like opening every door and window to your home and then going on vacation. Out of the box, switches and routers prioritize connectivity. They are designed to route data as efficiently as possible, which inherently leaves their digital doors wide open. This open default state is exactly what intruders look for. Threat actors actively hunt for these gaps, looking to gain access by exploiting software weaknesses or modifying code to bypass basic authentication. Effective network security involves a systematic, multi-layered mitigation process. Relying on a single software patch leaves the rest of the attack surface exposed. Defending a network requires adopting the attacker's perspective. This means treating the system as a stacked attack surface, where a weakness at any level compromises the whole. We model this attack surface as a 3D vulnerability stack. At the bottom is the physical layer. If a threat actor physically compromises a server rack, every firewall above it is useless. This physical vulnerability includes hardware fractures and environmental threats like extreme heat. Then we have electrical threats, voltage spikes, brownouts, or total power loss. Finally, there's poor maintenance, where disorganized cabling eventually takes the system offline. Before configuring a single logical access control, an organization has to secure the tangible environment. A shattered switch or a melted server results in a total denial of resources. On top of the physical equipment is the technological layer, where inherent code weaknesses exist. Next is the configuration layer. Here, default usernames or weak passwords create artificial pathways through the technology. Finally, the security policy layer. Failing to enforce access controls leaves all underlying layers exposed. This chart breaks down these three non-physical vulnerabilities. You can see how technological issues like unpatched firmware sit right next to configuration errors like default settings and policy failures like missing written rules. They are distinct categories, but they are entirely dependent on one another. A vulnerability at any single point in this stack, whether it is a missing policy document or an open port on a switch, compromises the integrity of the entire vertical structure. Attacks begin with a reconnaissance phase. Attackers map the target's IP address space and probe the vulnerability stack for any unsealed gaps. Once that weakness is napped, the attacker accesses the network to deploy a specific malicious payload, broadly known as malware, code specifically written to damage, disrupt, or steal data. This table defines the three main types of malware, categorized by how they travel. The first is a virus. A virus inserts a copy of itself into another program and relies entirely on human interaction, like a user executing an infected email attachment to spread. Worms, by contrast, are standalone software. They enter through a system vulnerability and travel the network unaided, multiplying as they go. Finally, Trojan horses are harmful software disguised as something legitimate. When users are tricked into downloading them, they open a persistent backdoor, giving ongoing access. By conducting thorough reconnaissance first, the threat actor knows exactly which malware type has the best chance of slipping through the specific cracks in the vulnerability stack. Once inside the stack, objectives fall into a few categories. Often it's extraction. Information theft involves breaking into a system to steal confidential data, like R&D files. Identity theft goes after personal information, allowing the actor to make unauthorized purchases. Other attacks focus on destruction or covert alteration. This image compares data loss against data manipulation. On the left, a virus reformats a hard drive, resulting in total data loss. On the right, data manipulation is quieter. The attacker changes an item's price without authorization. The final threat category is disruption of service. As this diagram illustrates, an attacker can overwhelm a target web server with a massive flood of malicious traffic. The server becomes so busy that legitimate users are completely blocked, often seeing a 404 error. Whether the result is a massive denial of service or the quiet manipulation of a pricing database, the root cause is identical. An unmitigated vulnerability within the 4-tier stack gave the attacker a way in. Every successful attack follows this exact trajectory. An attacker probes the perimeter, finds a configuration gap, bypasses an unenforced security policy, and delivers a payload that ultimately brings down the infrastructure. The countermeasure to this cycle is device hardening. This is the continuous, proactive process of configuring switches and routers to enhance security. It means turning off default settings, sealing unnecessary pathways, and applying rigid logical access controls. By enforcing strict policy and eliminating vulnerable defaults, administrators lock down the attack surface, stripping away the openings an attacker relies on during initial reconnaissance. A secure network does not happen automatically. It is an architectural achievement built layer by layer, requiring constant vigilance and rigorous multi-layered hardening.